First, if you're the kind of person who likes to plan vacations in advance, say several centuries in advance, have we got a destination for you? Here's the travel agent to explain.
Here on Kepler Object of Interest 314.02, you're a long way from Earth. Over 200 light years. Love sunshine? One hemisphere of the planet always faces its star. But if you're in the mood for serious moonlight, the other hemisphere is always after dark. Like base jumping or hang gliding? KOI 314.02's low gravity allows some spectacular heights. KOI 314.02 is yours. Tickets available in 300 years, plus or minus 1 century.
Okay, so you don't expect to go exoplanet hopping anytime soon, right? Well, we've got that nagging question of interstellar travel to untangle first, don't we? But this week, John Hockenberry, host of PRI and WNYC's The Takeaway, did ask two astronomers to think like interplanetary travel agents. He wanted to know, what might it be like to visit an exoplanet? Given what we know and what little we know about them, is it possible to imagine what it might be like to set foot on a KOI 314.02 or a Kepler 438b? We have the Takeaway to thank for the priceless Kepler ad, by the way. John Hockenberry joins me now to talk about the Takeaway's week-long exoplanet tour, which wrapped up this morning. Good to talk to you, John.
Hey, it's great to talk to you, Ira, and the thanks all go to our staff. My staff here is really great. Jay Cowett and Berkeley, who's the producer, who also is the voice of the travel agent there. And, I think the imagining of living somewhere far away, a different planet, that sort of thing, even outside of the solar system, is an old dream. But there's a lot new going on in the Kepler mission and in the thinking about exoplanets, and that's really what we were trying to get at.
Yeah, well, what fascinates you about exoplanets? You've been covering them all week.
Well, I'll tell you, the thing that is amazing to me is, you said that we asked some astrophysicists and astronomers to imagine what it's like. What we really discovered was that, in fact, they're already doing this, that we've passed a really important scientific milestone in that the space program and that astronomy and that the sort of interdisciplinary qualities of planetary study are coming together, and we are at a moment in human history where it is actually time to scientifically think about what it would be like to travel somewhere outside of the solar system and to think about what it would take to actually live there. And that's what these planeteers, exoplaneteers they call themselves. Sara Ballard was one of the people we spoke with, and Natalie Batalha, the other one. They're actually rigorously scientifically taking the data from the Kepler telescope, which is fascinating in its own right, and trying to extrapolate from that what it would specifically look and feel like if we were creating a mission to go to various exoplanets. And there's amazing stuff. You can find it at thetakeaway.org, but I can give you a preview of the two places that we really looked at closely.
All right, let's talk about your first stop. Your first stop was Kepler 438b. Tell us a bit about what that exoplanet could be like.
Well, 438b is an exoplanet with a moon around it. And it's a gas giant planet, which was detected by Kepler because it comes into the stellar light and dims the light enough so that they can begin to estimate what the mass of the planet is. There actually have not been any exomoons discovered, but because the gas giants like Jupiter and Saturn in our solar system have a large number of satellites around them, they only assume that there must be moons, and there's actually a very strong suspicion that some of the most habitable places, like Europa and Io in our solar system, would be moons of gas giants. And so this place is very, very small. It would have very low gravity, and there would be a constant sort of gas giant. This planet would constantly be in your face on this planet because it orbits the moon and not the star. It has odd seasons, and the what makes it more likely to be habitable than not is that it gets a very steady amount of sun, because it's not orbiting the sun and it's not rotating, it's orbiting around the planet. So that was one of the things that they discovered, thinking about the exomoon.
Yeah, I want to play a clip, and this is astronomer Sara Ballard's educated guess about what it might be like to land on KOI 314.02.
One of the things that I think would be first impressed upon you as the staircase of the spacecraft unfolded toward the solid ground is the mountains loom impossibly large. Mountain ranges on the Earth, they're never allowed to get too high. The gravity of the Earth pulls them back down. On this planet, the gravity is so much less, you can feel it in your own body. And without that strain, that strong resisting gravity, they've stayed very, very high. And creatures could probably evolve to be larger.
Very interesting. Large mountains, large creatures. John, what else did Sara Ballard have to say about this place to visit?
Well, one of the things I loved about talking with Sara is she speaks so confidently. She's obviously so young, and she's talking about 314.02. Boy, those NASA people have really a thing with names, don't you think? KOI, Kepler Object of Interest.
They should call that pi, that planet pi, with 314.
Real poets. Yeah, I know. Isn't that interesting? Anyway, she's talking about the gravity being low, and so therefore that means that the tectonic plate activity, or the geologic activity of any kind, the magma, that sort of thing, is going to be magnified in terms of how much distance it would cover. So the mountains would be higher, the earthquakes would be sort of bigger, the geysers would be taller, and all of that. The concern about this planet, though, and she was very convinced we couldn't actually live there, is that the only place you could really find a possible habitable zone would be right at what's called the terminator, where the sunlight and the darkness come together, and that's because it's like Mercury. One side faces the sun, the star in this case, all the time.
John, thank you for joining us. I know you had a swell week, I'm sure, as we used to say, in covering the exoplanets, and we'll take a look at your website and find more about them. Thank you for taking time to be with us this week. And have a happy...
Ira, it's always great to talk to you.
Have a good weekend. Yeah, John Hockenberry, host of PRI and WNYC's The Takeaway, talking about exoplanets. And if you want to know more about them, you can go to our website at sciencefriday.com/exoplanets, and we'll link you right up to their program. Of course, the big question on any interstellar traveler's mind has to be, is there life on exoplanets? Sara Seager has been asking that question her whole career. She never gets tired of asking it, and we're glad for that. She's a professional exoplanet hunter, professor of physics and planetary science at MIT. And this week in the journal Science Advances, she explains how telltale atmospheric gases let's use atmospheric gases to find and see if there's, E.T. lives there or there's any kind of extraterrestrial life. Welcome back to the program, Dr. Seager.
Hi, Ira. It's great to be here.
What do you think about these exoplanets we've been talking about? We don't know that KOI 314.02 has mountains, do we? Know that for sure?
No, we don't know at all. We don't have any real evidence of it, but we do love to speculate.
Yeah, we got to get a better name for these planets.
Well, we're fighting over what to name them. No one thinks it's fair if their friend names it and not themselves.
Exactly.
So we're working on that.
Yeah, there's always some sort of fight going on. Let's talk about the theory of analyzing the planet's atmospheres. It sounds very logical. If you want to know what's going on there, see what's happening in the atmosphere.
Yes, well, here on Earth, microbes and humans and all creatures use chemistry to store energy, and molecules get released as byproducts that, in some cases, fill the atmosphere to detectable levels.
Mm-hmm. And so what kind of level, what would we be looking for then in the atmosphere of the exoplanets?
Well, we kind of go back and forth, and this kind of topic has been around for many decades, since the 1960s at least. And our prime one now, in a very sort of self-centered way, is to look for oxygen. Our own planet has oxygen filling the atmosphere to 20% by volume, but without plants and photosynthetic bacteria, we'd probably have no oxygen.
Huh. But does that mean that there would be no life? Could there be life that didn't depend on oxygen?
Well, absolutely. There is life on Earth that lives in the deep sea that doesn't depend on oxygen. We didn't have oxygen on our planet for quite a long time early on. So it's absolutely a possibility. And so, as we're getting closer and closer to the day when we can look for signs of life, we're starting to rethink the problem.
You mean that you could argue that we've been sort of too terracentric and thinking about using what we know about life here on Earth to look for life some other place.
Absolutely. And just like you heard Sarah Ballard talk about that, hey, with a low gravity, that planet may look totally different. It's the same with life. We may have life that also uses chemistry on planets far away, but their chemistry may be different.
Have we actually been able to analyze any of the exoplanet atmospheres so far?
Well, amazingly, we have. And we have at least about 10 of them where we have fairly good data in analyzing the atmospheres. But these aren't small rocky planets that might have life. They tend to be hotter, bigger planets.
How many exoplanets have we discovered so far?
Well, so far we have about 5,000 exoplanets. Some of them we've verified and some we're still are on the list of candidates that aren't verified. But not only have we found 5,000, but astronomers have determined, statistically speaking, that every star in our galaxy should have at least one planet.
Every one of them?
Mm-hmm. Every one of them.
I'm trying to calculate on my fingers and my toes how many.
Right.
That's billions, right?
Right. Well, we think our galaxy has hundreds of billions of stars. And if each one of those has a planet, and in our universe we think we have hundreds of billions of galaxies, try to count that one.
Is that
how many planets
is
are
that
there.
is that a new idea? How many that they should have? We didn't think that many before, did we?
Well, we didn't know, but it turns out that most stars we see form with a disk of gas and dust. And so we thought that leftover debris forms into planets. So we were thinking that planets were quite common, but we just didn't have any real measurements until not too long ago.
And any guess on how many of those might have, intelligent life? I know this is really out on a limb here.
It is on a limb, and so we never like to answer those questions because it's just, my guess is as good as yours, Ira, or as good as anybody today listening to the program. Instead, we like to say, we're trying to evaluate that by first finding out how many habitable planets there are, and second, by looking for signs of life of any kind, microbial life or anything on them. And when we have that information, we may be able to speculate a little more concretely.
Well, my guess will never be as good as yours. We're going to take a break and come back and talk lots more with Sara Seager. So stay with us. We'll be right back after this break. This is Science Friday. I'm Ira Flato. We're talking this hour about the search for life on exoplanets with a professional exoplanet hunter. Sara Seager is a professor of physics and planetary science at MIT, and she writes this week in Science Advances that biosignature gases might be the telltale clue that points the way to life. If you'd like to talk about that with her, please do. Our number, 844-724-8255. You've been working on a project with NASA called Starshade. Tell us about how that might help us detect these gases.
Well, let's back up and say that a lot of the planets we found, we can't look at them closely because the planets and stars are just too far away. We need to find planets that are Earth-size or might be like Earth around the very, very, very nearest stars to us. And how we're going to do that is we'd like to block out the starlight so we can just see the planet directly. And the starshade is essentially a giant screen that would go in space, and it would block out the star so that only planet light would be seen by the telescope. It's just like if you go outside on a bright sunny day and the sun is in your eyes and you stick your arm out and you put your hand in front of the sun and block it out. Except instead of your hand, it's a giant screen. And instead of your eye, it's a telescope very far away from that giant screen.
The screen looks like a giant sunflower.
Yes, it looks like a flower.
Yeah, we have a simulation of the starshade deploying at our website at sciencefriday.com/exoplanets. Does this really exist? Is it a prototype or?
It absolutely exists in terms of a prototype in the lab. And it's being tested, and technology has been developed in all sorts of ways. And I actually have just 2 weeks ago, I've been leading a team for the last 18 months, and we briefed NASA on the progress of the project. Essentially what exists are flight-like petals that are about the right size. They're about 5 meters long. That's about 18 feet or a little longer. And a central truss to which they would attach to, which itself is about 15 meters in diameter. So we have deployed it in the lab, not myself, but this is out in California at Northrop Grumman. All sorts of tests are being done. The science has been studied, and we're really excited about this project.
Sara, I'm going to give you the question I give a lot of scientists. Probably gave it to you one time before when you were here before, and that's my blank check question. If you had all the money, a blank check you could spend on searching for exoplanets and the gases in the atmosphere, what would you do? What do you need? Maybe we can get some interest here for you.
Right. Well, we would absolutely do the starshade where we have a plan. We know what technology gaps we need to close. And it has a really amazing ability to block out the starlight. And we would build it effectively so it could work with either an existing telescope or we would build a new telescope. And we would literally search every single sun-like star near to us.
You'd have a lot of years of work coming up, wouldn't you?
Well, the funny thing is we know exactly what to do and how long it will take and how much it will take, because part of our exercise was like a costing exercise. So we believe it's possible. And, the great thing is that with the Kepler Space Telescope, we now can say for sure that small planets are extremely common.
Yeah.
And, you talked with John and others about how they're in the habitable zone even. So at this point, like as compared to the last time I might have talked to you, we know that the planets are out there. They're just waiting to be found.
Let's say we were looking at Earth from the same distance that we've been looking at these exoplanets. Would we have any clue that life was here? And what would we see?
Well, first of all, what we would see, do you mean if we could do the star shade or like with, well, we would actually, what we'd see? We'd see a pale blue dot. We'd just see a tiny, tiny, tiny little speck covering maybe 1 pixel of our camera. So we'd really see almost nothing. We'd just see a color that it's blue. And what we'd need to do is take that blue light and analyze it further and look for gases that might be in the atmosphere. And people have actually done this study. We've used spacecraft, not as far away as the other stars, of course, but spacecraft out heading towards Mars to look back at Earth and to look at it as an exoplanet. So we have studied Earth as an exoplanet.
Didn't Carl Sagan do that with Galileo at one point?
Yes, he did actually. He did an amazing experiment. When Galileo was on its way to Jupiter, it did a gravity slingshot on Earth just to gain speed. And he had it turn on its instruments and look at Earth. And his team asked the question, assuming we know nothing about Earth, could we infer that life was there? And I just read his paper again recently. It was so beautifully written because he didn't say, yes, we absolutely discovered life on Earth. This is a done deal. It's robust. He said, well, we have found 3 things that are strongly suggestive of life on Earth.
Speaking like a scientist.
Yeah,
Yeah,
that's right.
Dr. Seager, it's always a pleasure to have you on the program. Thank you for taking time to be with us today, and good luck with the exoplanets.
Thanks, Ira.
Please come back anytime you'd like. Sara Seager, professor of physics and planetary science at MIT. Her review article on biosignature gases appears in Science Advances Today. This week, you may have been lucky enough to observe a rare celestial occurrence, and that is the transit of Mercury across the sun. And as Mercury sailed past the sun, it blotted out a tiny bit of the sun's light. It's so small it appeared like a black dot, like a period, slowly pushing its way across a great ball of light. Well, that same idea, observing a planet as it passes the face of its star, happens to be one of the key ways we detect exoplanets, too. These are planets outside our solar system. And this week, scientists from NASA's Kepler mission announced a huge new haul of planets, 1,284 exoplanets, huge, as we say today, added to our roster of known worlds beyond the solar system, which makes a total of over 3,200 planets we know of out there in the great beyond. So next time you look up in the night sky, instead of seeing just stars, you might do as my next guest does and imagine each of those stars as a solar system, a whole solar system instead. Natalie Batalha is Kepler Mission Scientist at NASA Ames Research Center in California. Welcome to Science Friday.
Thank you so much. It's a pleasure to be here.
How exciting is this?
It's been a great week. Yeah, it's been a long time coming. We've been working on this methodology and this paper for several years. It's a methodology that's been in the works for a long time.
So it looks like there are a lot more of them out there than we ever thought or believed.
Exoplanets, you mean? Yeah, absolutely. As we look at these discoveries that are rolling in from Kepler and we crunch the numbers, we quickly realize that every star out there has at least one exoplanet orbiting it.
And Kepler was looking at just the tiniest patch of sky.
Yeah, you hold up your hand outstretched, kind of like a police officer saying stop. That's the size of your hand. Outreached hand is about the size of the sky that we're looking at. So it's 10 degrees by 10 degrees on the sky.
So if you were to extrapolate those results to the whole galaxy, how many planets might be out there?
Oh, we're talking billions. We're talking tens of billions. Even if I isolate the population to really the ones that we're very interested in, those that could potentially harbor life, as we know it at least, that number is in excess of 10 billion in our galaxy alone.
I'm just blown away by that number. Wow. Wow.
Yeah, it tells us that there's a lot of possibility, right?
Yeah.
And of the planets that we have found, the diversity is so great. We're finding worlds that we couldn't have imagined before. Maybe George Lucas could have. He had the world Tatooine, where you have the planets orbiting 2 stars instead of 1. We've got lava worlds, just an enormous diversity, planets that we don't see in our own solar system. So nature is quite grand.
I'll bet. And now, is Kepler basically on a census mission, trying to get a tally of all these different kinds of exoplanets?
That's right. We're taking a census of sorts. It's like calling up 1,000 people and finding out who they're voting for and extrapolating that to the larger population. We're surveying about 200,000 stars, looking at the planets that are orbiting them, at least within what we call 1 astronomical unit, kind of an Earth orbit and inward. And then trying to understand, based on those results, what the population of planets is in the galaxy.
Mm-hmm. These new planets we're talking about, the 1,200 new planets, they were actually spotted a while back, right?
Yeah, we saw evidence of their existence in the periodic dimmings of light that we observe. But when we see those tantalizing signals in the data, we don't jump the gun. We call them planet candidates. And the reason for that is because there are astrophysical signals in nature that can mimic these periodic dimmings of light. And so we have to do due diligence. We have to weed out all of these potential imposters in order to really say that this is a bona fide planet.
Mm-hmm. And one of the interesting things in all your data of planets is that there is a real abundance of planets that seem to be between Earth and Neptune size, something that we don't really have in our solar system, do we?
Yeah, that's exactly right. So in our own solar system, we've got the small rocky worlds, what we call the terrestrial worlds, orbiting close to the sun. We've got the gas giants orbiting far away. And the leap in size between those populations is like a factor of 4, right? Earth being kind of the biggest thing among the terrestrial planets at 1 Earth radius. Neptune would be the next. That's 4 times bigger than Earth. And so in between, we don't really have anything in our own solar system, or at least we don't think we do. I'll be a little mysterious there. But yet, the most common
Say that
planet...
again?
Well, I was alluding to the possibility of planet 9 in our own solar system. Looking at the gravitational perturbations of the Kuiper Belt objects, and maybe that's an indication that there's another planet out there, and maybe it fits in that in between sizes, something in between Earth and Neptune. I don't know. Time will tell. But these kinds of planets in that size range are actually the most common planet known to humanity right now.
Huh. What planets out of this latest batch are your favorites? Which do you think might be the most interesting?
Oh, goodness. Well, I'm intrigued by the lava worlds. I'm intrigued by the photodisintegrating planets that we see, planets that are literally breaking apart before our eyes. They're emitting these huge cometary-like tails. It might give us an opportunity to sample exactly what planets are made out of. So I'm intrigued by those. I'm intrigued by these super Earths, or what we call sub-Neptunes, this in-between region that you talked about. I'm also very intrigued by the oldest planets that we are finding. There are planets in the Kepler catalog that are as old as the galaxy itself. And that, to me, was a very surprising result, because when you think about the building blocks that are required to construct a planet, it wasn't really obvious to me that those building blocks would be available when the galaxy was in its infancy.
Wow.
But yet, here we've got these planets, and I'm intrigued by the idea that there are planets out there that are twice the age of the Earth. And I wonder, given that much time to evolve complexity and evolve life, what are the possibilities?
No wonder you just can't go out and look at the sky and just look at a star anymore.
It does tend to change one's perspective. That's right.
Is the ultimate goal to find life? Or is it just to understand the planetary formation, as you say, the history of the galaxy and so on?
Both of those things are tremendously important, and depending on which scientist you ask, you're going to get a different answer. For me, certainly my passion for science is driven by the search for evidence of life beyond Earth. And so NASA does have a kind of long-term vision or roadmap, if you will, for doing exactly that. It's one of the primary, science goals of NASA's astrophysics division. Absolutely.
And how could you not believe it? You said there were tens of billions just in our own galaxy here.
Right.
How could you not believe that somewhere there's going to be some form of life? It's almost just like a certainty.
Yeah, you're preaching to the choir. I believe that as well. If I have to use that word, believe, just as a hunch, it would be a terrible waste of space, of course. But the reality is we don't know, right? I mean, we've got these Goldilocks worlds. These are planets where there's the possibility that liquid water could pool on the surface, but that doesn't tell you what fraction of those are truly habitable environments where there is liquid water and where life could flourish. My impression is that microbial life is going to be ubiquitous on these worlds. Whether or not there's additional complexity or intelligent life, I don't know. Maybe that is even yet rarer still. But time will tell. We have to do this systematic methodical search in order to answer that question.
Will the upcoming James Webb Telescope help us get a closer look at any of these?
The James Webb Space Telescope is going to look at exoplanets, absolutely. It's going to do something called transmission spectroscopy. We want to feed James Webb some of these transiting planets that we have found. They're very special for the following reason. When you have a planet transiting across the disk of its star, some of the starlight is going to filter through the atmosphere of that planet. And in doing so, the atmosphere is going to leave a chemical fingerprint on the light that's streaming through. And so the James Webb Space Telescope will be able to catch that light, spread it out into a spectrum, and see those chemical fingerprints. And that's going to tell us what those atmospheres are made out of.
Wow.
Now, the big question is, can it do that for potentially habitable Earth-sized planets? And there I'm kind of skeptical. I think James Webb is going to be really great at characterizing the atmospheres of the Neptunes, the sub-Neptunes, and if we get lucky, maybe a smaller planet like Earth. But I think that remains to be seen. We'd have to get really lucky.
A couple of listeners' questions. One tweet from Patrick Fire says, can your guest speak a little on how you determine the age of an exoplanet or the composition of it?
Yeah, great question. We can do that by looking at the star itself. So we have a lot of information about the star. In some of these situations, we have what's called astroseismic information. We can see in the brightness measurements, we can see pulsations of the light that's coming from the star. Those pulsations are starquakes that are causing the light to vary at very high frequencies. And by analyzing those starquakes, you can actually get the fundamental properties of the star itself. And one of those fundamental properties is the age.
Wow, there you have it. We want to wish you the best of luck in doing this, Dr. Batalha.
Thank you
we
so
hope
much.
And the Kepler spacecraft itself, is it in good shape, or is it having a problem?
It's doing fantastic.
Okay.
It was hobbling along
Had a
for a
hiccup.
little while. It had a hiccup. It lost a reaction wheel. The engineers resuscitated it, and it's been operating ever since. It's taking data. It has enough fuel on board to last until about mid-2018, I think is the current projection.
All right.
So it's doing some great science.
Natalie Batalha is Kepler Mission Scientist at NASA Ames Research Center in California.